Okay, so what they're trying to do here is now, instead of just doing a discrete number of triangles or rectangles, now we're kind of write it as an expression that shows what happens when we go to an infinite number of rectangles. And that's what this Riemann sum, and there's different versions of how to write this. This one's a little more formal. Basically, what we're trying to do is we've got, so like this function is what, 4x cubed. So 4x cubed, we know, looks something like this, right? It's a stretched cubic function. And we want to know the area here. Let me get a different ink. We want to know the area between the x-axis and the curve. So we've got this area here, and we've got this negative area down here, right? Let's see, red pen. Okay. And there's a lot of ways to do that. I mean, ways to come up with an estimate. But basically what they're saying, see, I kind of drew 3 rectangles. What kind of rectangles? If I, depending on whether I want to use middle or left or right. But if I go to infinite number, I get even a better estimate, right? You learned about that in section 1 and 2. So what we do is, this format says, if here's the definite integral, we're finding the area from -1 to 2 in this case, for that function. The way you set it up is basically, this is going to be the length or the height. This will be the height of the rectangle, and this will be the width of the rectangle. Length or width, the height and base, I guess we could call it. Height and the base, length times width. And what we do is, how far apart. So see the b minus a, where b is the right-hand bound, a is the left-hand bound. So if we do, let's see here if I can see what I'm writing. Let's see, so 2 minus 1, this is the b minus a. Doesn't that become 3? And 3 over however many rectangles we want. And then what we do is we drop it into the function. See the way it says, they kind of hide this a little bit. This is basically f of x. And they're saying the x is, here's how you get all the x values that you're going to try to find the height. See, if I want to do remember, if we want to do a right ram for this, I mean a left ram for this, what I have drawn, I would find, with 3 rectangles, it would be 1 wide times whatever f of -1 is, plus 1 wide times whatever f of 0 is. Of course, we can see that 0, right? And then the next one would be 1 wide times whatever f of 1 is. And of course, that's an underestimation. Okay, so that's what this expression is saying. To find all your heights, you're going to do start at -1 and add on that little increment, whatever the increment is. So, and how do you write that? How do you find that? Well, they kind of give you this nice formula here, where a is your lower bound and k is for whichever one you want. See, they're saying as k goes from 1 to an infinite number of rectangles, some k times however wide it is. Notice that this expression is exactly the same as this expression. So once you know it's 3 over n, it'll be k times 3 over n. And that's that Riemann sum. That's how you write that expression. The area under the curve and between the curve and the x-axis as a limit of an infinite number of rectangles. That's what we're trying to say here. And then the second part of this question asks us find the exact value. And in the lesson, in next section, in section 4, you're going to learn about the fundamental theorem of calculus. And they kind of throw it at you as this rule here, this formula here. Here, let me show you, point it out to you in the book. Let's see here. Let's come over here. See how they give this to you in this book? They say find if the function you're want to find the area of is 1x, the antiderivative of that will be 1/2 x squared minus 1/2 x. So let's get a little formal here. I think it's good to learn that formal way to write that. I don't want to erase this. Here, I think I can do it this way. Here. So basically the antiderivative of x is 1/2 x squared, right? And then we're going to evaluate that from a to b. So that's why they're saying 1/2 b squared minus 1/2 a squared. And they wrote it as over 2. Okay. But that's the same as 1/2. So that's what we do. You find the antiderivative, substitute in the right-hand numbers, minus substitute in the left-hand number, and then that gives you the exact value. Pretty powerful way to do it, really. So what do we do here is I come back here, and that isn't what this one is. Let's clear all drawings here. Now I think I can here. Can I come back and write on this? Let me see. I think I can. So the antiderivative of 4x to the third is, let's see, we're going to add 1 to 3, make it be 4, then we divide by 4, so that just becomes x to the fourth. So we're going to evaluate x to the fourth from -1 until 2. So 2, let's see, so 2 to the fourth, let me write, I'll substitute it in. 2 to the fourth minus -1 to the fourth, well, that's going to become 16 minus, let's see, -1 to the fourth power is 1. So 16 minus 1. So that area is 15 square units. Okay, and that's all they're asking you to do here. Write the Riemann sum and then evaluate it, find the antiderivative and evaluate it this way with a right-hand bound minus the left-hand bound. Much, much slicker than trying to do all those rectangles. Okay, then the challenge becomes finding all those antiderivatives. Okay, so hopefully this helps.